So next we can talk a little bit about Ethereum structure. So Bitcoin transactions uses UTXOs and stuff like that. Ethereum transactions use smart contracts and the concept of account. Let's talk about accounts. We talked a little bit about smart contracts already, but let's talk about accounts. So there's two types of accounts. And the first is an EOA, which stands for externally owned account. And essentially, there are accounts that are controlled by private keys. So they're your most common type of accounts. So for example, your personal crypto wallet is an EOA, assuming it's on the Ethereum blockchain. And an EOA account is needed to participate on the blockchain Ethereum network, and that makes sense, right? You need a wallet to be able to participate on the network, and it interacts with the blockchain using transactions. And obviously, this makes sense because the main method of interaction between the blockchain and my crypto account is the transactions I make. The second type of accounts is contract accounts, or CAs. And essentially, these are accounts controlled by the code. So they're not owned by anybody, they're owned by the blockchain, and they can be activated by an EOA. So what contract accounts do is that they represent smart contracts. So every contract account has a balance, and then when you make a transaction, it's able to take the money that you send through the contract account and then put it on the blockchain. So think of it as an intermediary step between your account and the blockchain. And yeah, it's the accounts that are essentially needed. Essentially, accounts that are needed to help people make transactions. And then let's talk about transaction structure and criteria then. Transaction structure, there's a few more elements here compared to Bitcoin transactions, because of course, smart contracts and accounts and everything. So the first is a recipient. We've already seen that. Second is the digital signature of the sender. We've already seen that. So for example, their key, their public key. The amount, we've also seen that as well. And fourthly, what's a little bit more unique about smart contracts is an optional message. For example, the conditions in which you can spend the money, etc. Fifth is something called start gas, and it's the number of computational steps that the transaction is allowed. So think about this like fueling up your car, and because you have a limited amount of fuel, you can only go so far before running out of fuel, and that's essentially what the start gas is essentially fuel for transactions. How many computations are they allowed to make on the blockchain before they run out of gas and can't be completed? Number sixth in a Ethereum transaction is the gas price. So the fee that the sender has to pay in order to compute the transaction, right? Of course, using the computational power of the EVM, we need to pay some compensation. And then similar with the Bitcoin transactions, I can show the Ethereum transactions. So if we take a look at here, this is Ethereum, and we can take a random block. And so you can see that this is like what we've already seen before. So just blockchain and transactions. So we can take a random transaction. Oh, and also you might notice that there's no transaction number 0 or the Coinbase transaction, because there's actually no crypto mining on Ethereum blockchain. So there's no transaction number 0. So if you see here, you can see that there's a fee associated with the transaction. And so the fee is then the amount, or that's the amount you have to compensate the blockchain for computing the transaction. And overall, we can also see some different things the about a block in the Ethereum transaction compared to a Bitcoin transaction. So first, as I mentioned before, minted, you can actually have 0 Ethereum minted. That's because there's no crypto mining and there's not a guaranteed number of coins to be minted per block in Ethereum. Second is you can see the gas and the gas limit. So that's what we were talking about before. How many computations this is allowed to make. And yeah, these are these different things are mostly the same. So now um, now we talked about the transaction structure and criteria. We can talk about the block structure. Actually, I should go back to here. So in a block structure, there must be a block header, similar to Bitcoin. So that's not much different. Then there's also transactions, and that's not much different either. So the main difference between Ethereum and Bitcoin actually lies in the transactions themselves. So now that we talked so much about like second generation blockchains, specifically Ethereum, and their transactions and how the blockchain works, how does these type of blockchains actually still ensure validity and security in their transaction, despite being, not proof of work and not not like first generation blockchain. So that's where we have to talk about proof of stake. And so proof of stake is the other second type of validation protocol, other than proof of work, that some blockchains use. And we'll also talk about what's different, what's the same, and also how it sort of solves for the problems of. So first of all, what is proof of stake? So proof of stake is essentially, well, I should give some history about that. So proof of stake is the type of validation protocol adopted by newer generation blockchains. And so it's a second type of validation process. And yeah, now we can talk about how specifically it works. So instead of having crypto miners, recall that we talked about two types of participants: the normal participants and the participants that take on extra responsibility. In a Bitcoin or in a proof of work blockchain, crypto miners are the one that take on extra responsibility. They're called crypto miners. And in a proof of stake blockchain, the people that take on, or the participants that take on extra responsibility, are called stakers or validators. What does that mean? So under proof of stake, validators are chosen based on the number of staked coins they have. And what does staked coins mean? So staked coins essentially means putting your own money up as collateral. So collateral is like when, for example, you take a loan from the bank and they say, we put your car for collateral. So in case you can't pay back your loan, they can take your car. So validators put their coins and money up for collateral in order to receive the privilege of being the role of a validator. So for example, on Ethereum, it takes 32 Ethereum to become a validator. And so if I put 32 Ethereum on the Ethereum blockchain, then I get the right of becoming a validator. How specifically does, me staking my money actually work? Previously, when we talked about proof of work, the main way that it was able to keep the blockchain secure was through computations and just computing and hashing in order to verify the blockchain and the transactions. However, on proof of stake, the validators that are randomly selected to confirm transactions and validators are randomly selected to confirm transactions and validate block information. So what that means is instead of me, using my computational power to provide power a hashing function, I'm able to leverage my money and therefore make transactions. So the validator is actually able to validate or confirm or not confirm transactions. Of course, I can't, if even if I put up 32 Ethereum, I can't actually say, okay, I like this transaction, it's confirmed. I don't like this transaction, it's not confirmed. The um the Ethereum virtual machine does not. But essentially, validators get are technically allowed to confirm transactions. And and this system actually still prevents people from cheating or hacking or whatever because there's the collateral of your own money. And so the system randomizes who gets to, and another countermeasure is that the system randomizes who gets to collect fees, um, rather than using competitive reward-based mechanisms like proof of work. So how is this sort of different compared to proof of work? Well, in proof of stake mechanism, or how's this the same and how's it different? So a similarity is that proof of stake mechanisms still use various methods to reach a consensus. So, for example, Ethereum introduces something called a sharding, and a validator verifies transactions and adds them to something called a shard block, which requires at a maximum of 128 validators to form a committee. So once the transactions are compiled and this block is created, and if more than 2/3 of these validators agree and say, okay, yes, this makes sense, we validate this, this is correct, then the block is solved, not and broadcasted to the block. In a proof of stake, essentially the main difference is that because people are leveraging their money and assets rather than leveraging their computing power, it's much more energy efficient. So there's no hashing, there's no crypto mining in proof of stake, because of the way it's set up, and instead people leverage their assets, and that creates very little energy. So when we're talking about blockchains and their environmental impact, right? The vast majority of the environmental impact is not from, for example, the servers hosting the data of the blockchain. It's from the validation process of proof of work, as it requires massive amounts of computational power to run the hashing functions, or to hash and run the encryption functions. So when you only need to store some data on the blockchain, etc., it's really energy efficient. And another big difference is that is the security strategy or the verification strategy of proof of stake and proof of work. In proof of work, there's an expensive upfront requirement of different miners, like contributing their computing power and competing to make the new block. However, in proof of stake, it's security through validators sort of coming to a consensus, not through competition, but coming to a consensus in order to actually validate blocks. So what does staking look like from from like one person's point of view? So staking, obviously, not everyone has 32 Ethereum to stake. Just like not everyone has the computing power to compute and fully solve a block by themselves. So that's where staking pools are created. Just like mining pools, staking pools are places where people are able to, as the name suggests, pool and combine their money together in order to make that 32 required, or 64, or whatever, how many validating positions is the pool wants to get. But people are able to pool their assets together and then become a validator. And similarly to mining pools, the staking pools will of course reward participants proportionally to how much they contribute. So if I contribute more to the 32 Ethereums, I get more of the reward from staking. So of course this allows more people to participate in staking, just like it allows more people that don't necessarily have the entirety of the computational power to participate in crypto mining. And when we're talking about staking, one common thing that we might hear is something called yield. And so yield is, you can think about it as when you're investing in a stock and the stock price goes up, you have a yield from the stock. And similarly with staking, when you stake and then your validating of your validator position solves the block or comes to consensus to solve a block is where you get your yield or reward from. So going back to when we're talking about the block, we saw that in the Bitcoin block, there's newly minted coins. So there's a transaction zero that mints like 3.28 or something around that of Bitcoins. And that's the reward for crypto mining and proof of work. However, in proof of stake, it's the reward for validating a block. So that's the reward. So I guess to summarize the key differences, the first is that proof of stake does not require that much computational power as compared to proof of work. And the second difference is that in proof of stake, you stake your own assets and money, while in proof of work, you invest in computers and power costs and give up your computational power. And the last difference is that validators in proof of stake receive transaction fees as reward. So, as I said, they get the reward for completing or coming to a consensus and verifying a block. And while miners get block rewards. So I guess to contextualize that more is you can think about it as the miner's reward being inherent to a block. It's contained within the block. So if I'm crypto mining, my reward comes from the block that I solve. However, in proof of stake, if I stake something and I validate validate a block and therefore the transaction in it, the reward that I get is the transaction fees. And then this links back to when we're talking about how the gas fees, right? You need to pay a gas fee in order to make a transaction because you need to compensate the blockchain. And then these gas fees then go back to the validators. So I hope everything sort of makes sense altogether. So that's the end of the entire course. And so a quick recap of everything that we talked about is first, history of blockchains. We talked about how the double spending problem, talk about the solving the double spending problem and the creation of Bitcoin. We talked about creating a wallet, cold wallets, etc. Then in our second meeting, we talked about the structure of blockchains. So how blockchains have four main characteristics, how blockchains are applied in the world. And in our third meeting, we talked about proof of work mainly and first generation blockchain structures. So proof of work, again, is using hashing power provided by miners who are participants that take on extra responsibility as a means to power their function, their validation functions. And then in this meeting today, we talked about proof of stake, which is the other validation protocol for blockchains, which was created in order to solve the environmental impacts of proof of work. And it does this by setting specific people or groups of people in staking pools as validators, rather than making people contribute their computing power. And a final note before we end is, so today's the last day. So today will be, and in the beginning, I did promise everyone that I would send out some crypto. So today will be the last chance. I'm sending it out tonight. So if anybody would like to still send me their wallet address, you still can. But I'm going to be sending the crypto really soon tonight. But other than that, that's the end of the course. So I hope everyone enjoyed, and thank you for coming.